So I want to split. I'm going to split a couple of modules, and we're going to actually be working out of two, two modules for the rest of today, and then going into next week. So kind of where we're at, and unfortunately, I was out Monday and Tuesday, and is that right? Or Tuesday, Wednesday, sorry. And then I will be out Monday as well. So I'll give you guys assignments, and so you could work on some of that stuff at home, submit that stuff, and then we'll pick it back up Tuesday. We are at the point where I've held off the CMM, really getting into the nuts and bolts of the CMM as long as I could. So I've got some books coming for you, I've got some other software coming for you, we'll be updating and downloading as the semester goes. We want to get started in the CMM arm first, running full PCDEMIS. PCDEMIS is kind of your premier measurement software that almost everybody in the world uses. It's like G-code, so I mean it's not like G-code, but it would be comparable to G-code. It's the thing that all measurement systems are based off of, like all machining is based upon G-code. So what you guys did the other day, you did that Hardness Testing Lab. It's right here for you to submit your videos to. So it's actually in module 3. Might have to do a little bit of searching for it. If you will just, it's right here, sorry, it's right there, Group Heat Treat Lab. So if you'll submit that there for me, just of your group, if one person from the group will submit that. And then if you did one already for Hexagon RDS Quick Measure, that would have been, like maybe you came in Wednesday and did that, that's great. And then you can submit that in there. So we're kind of splitting those two modules. Today we are going to continue on with RDS a little bit. We'll finish up a little bit in RDS, and then we'll go straight into the Hexagon ARM PCDEMIS intro and start up with lab, and then we'll start talking about alignments. So not all of this will be finished up, so we'll carry module 4 into next week. Okay, so I'm not expecting you to do module 4 quiz over the weekend, so we'll catch that up over next week. So we haven't got through all of the information yet. So we will be getting into that, but so I think I want to start out like this. We've got some parts out right now. So you've got some parts that you checked, and then you have your heat treat samples. Tell me about your heat treat samples.
The O2 or the A2 is still in the oven. It's on its, should be ramping up its temperature for its final resting point, and then the O1 is 60 HRC, and the other one's 58 HRC.
Okay, so within 2 points on 6 to 59, let's just say 59 plus minus 1 on your Rockwell C for your O1. Mm-hmm. A2, you guys had a problem with some kind of error and had to restart.
Yeah, reheat, so we had to restart.
Right. So that happens. You know, it's kind of just like it's like a CMM program. It's like a laptop not starting up. It's like a 3D print going wonky. It's rare, but it does happen. And so with our materials that are pretty high carbon, we're safe. We can do another heat treat process for that. If it's just 5 times that this happens, we've probably lost the carbon in the piece of material. We're going to have to start thinking about doing some other things to try and save it. Carbon packing isn't really an option on most parts. That's where we're going to send somebody and have them cryo it or do something to try and save it. So they're going to reverse the heat treatment process and actually do kind of a freeze process to harden it. So so that happens. But okay, so tell me about. Give me your other examples from your heat treat samples. What other group had good heat treat samples, bad heat treat samples? What did you guys have?
Our second time turned out pretty good.
Okay, so first time, what happened?
I don't think fire rate was all good.
Okay. Yeah, so lots of times you don't go quite hot enough. You've got to be in the zone on, it's just like baking a cake. You've got to be, A2, you've got to be about 1750. You can, I always would say this, and I don't know that I would always say this, but 99% of the time I would say, you can overheat, you cannot undercook something. And so I think we said that like chicken, right? So you can always overcook it. It might be a little dry, but undercooking it makes you throw up or poop your pants. So Either way, those are bad, so don't undercook your metals, okay? And then what'd you get for Rockwell values?
You guys know what we got? It's like 60, 65.
60 to 65. 65 is on the super high scale. And so we're gonna try to pull those back down, here as we go. So, even 60 is really pretty high. Okay, what other group? Cameron, your group consisted of who? You two?
Yeah, it would have been Dylan as well, but he's out.
Dylan's out, right. Dylan's still out. He'll be back Monday. He thought he was gonna come back today. He's like, I feel really good. Now I feel like crap. And I was like, Monday it is. So don't bring your nasty germ fever, the 119 fever in here. You know, you're gonna heat treat somebody.
We won't be here Monday though. Didn't you say it would be?
Right. But he's in another class in Monday morning. Yeah. So I was like, come on in Monday, do your thing. So he's with Clint Monday morning.
We don't have a class Monday.
No, you would know that if you were in here at the beginning of class. Yes, that's right, I will be out Monday. So I will give you some assignments, you just work on that stuff online, and then you can submit it, and we'll be good to go. So we'll pick it back up on Tuesday. So I've gotta go to Wichita, Monday, so we're touring another machining program, that we're doing some modeling, benchmarking is what we're calling it, so we're modeling off of another, NC3 school, so. Which is really great for you guys right now, because what we're trying to do is we've always said our goal was to be the best machining program in Missouri, and somehow suddenly we just really started to kick that into gear, and we were like, what does it take to be the best machining program in Missouri? So we're going to other states and checking out some of their best machining programs in their states, and so we're just checking those out and sabotaging some stuff there, and then we'll leave, you know, so.
So what I'm hearing is you would make an EMP.
I would not say that, because we are currently being recorded right now. I would never, ever promote anything like that. I think we should just hug and get along, so, everybody be happy. So, yeah, they've got a great program, they do a lot of NC3 stuff, they do a lot of NC3 certifications, so, we're taking best practices from them, and then we're just copying them for ourselves, and then we'll tweak up to what we're doing. Right now, school-wise, we've got a ton of stuff going on, we're building this giant fab lab, along with the new building. Sometime I would like us to get a chance to go over to the new building. I already know what it looks like when it's built, you know, cause like I was part of the building, the kind of the layout of it. The new building is going to be so super ultra fantastic. I mean, yeah.
What is it?
The new machining building, that building that's over there.
I did not know.
You have not seen a big, large building being built?
I've seen it, but
Okay.
I just didn't know what it was.
It's the new machining and welding building, yes. So, front part of it is all machining, beautiful, it doubles our space. Even the CTC goes over there, so, it'll be double the space for everything. Yesterday, when I was gone, I was actually talking to Haas about ordering 12 new machines. And so, what's crazy is on new machines right now, some of them are 24 months out for delivery, for chips. So like, they could probably bring the machine here, but it'd be like all those F-150s that are sitting in parking lots that just don't have chips in them, you know, so. They said that for the machines that we're looking at, those are some of their best sellers, so those are still being sold. So we don't have to wait 2 years to get those machines on our floor. But, anyways, lots of movement happening in the machining program, so it's really a cool place for you guys to be in, but it makes it a little bit of a chaotic place. So I'd hope to have all 3 of these new CMM arms going. We're gonna start with this one, we'll pick the other ones up as we go. So, one of them came in yesterday. It is like the ultra big brother to this. So this is an 83, I think that's like a 95. It's about, so from the table, it's about to here. With it, and then it stretches out. I mean, it could almost reach Jeff's beard. That's how long it is. It's pretty impressive. So, and then soon you guys will be able to, you know, work on those things by yourself, check all your other parts. And so, like I was telling some of you guys earlier, when y'all are in your 101 class, if you've already been trained on a piece of equipment, optical comparator, CMM, hardness tester, whatever it might happen to be, you are welcome to check your dimensions and diameters and all those other things using all of the stuff, okay? So I don't want you to think just in the box of Clint has me checking these things with the dial calipers, with the micrometer, don't be afraid to come in here and as you're checking these janky things that y'all made, to be like, hey, I wonder just what there's, I need to double check on my diameters. And so don't be afraid to use all the equipment that we have. And at some point, I hope that you guys will get to the point where you can drop one of these things in, check the diameters, check the lengths, and just be golden. And so I want the more time that you can put your hands on these pieces of equipment, don't be afraid of this. This is meant to be used. And so more time that you can put your hands on this equipment, the better that you're going to be. So I would just really encourage you guys to do that. So today we will go through, I'll talk just a second about quick measure because we had a little bit of some questions about some things. RDS and what it'll do and what it won't do. There are some limitations in it, and it's only meant to be that super simple setup as far as hole to hole, point to line. Jeff and some other people were in here talking, and they said, "Hey, how do you do like a line to a circle without doing some math?" It's just not an available option on this. So it's like the microwave where you really want 1 minute and 37 seconds, and it's got a minute and a half, and 2 minutes. So you hit 2 minutes, and you just hit door open before you get to it. So sometimes you just got to make some adjustments in it. But RDS is really just one very small part of what the CMM is going to do. And we'll get to that here momentarily. I've got some parts that I want you guys to check. And but before that, so everybody has heat treat samples done, correct? Does anybody not have heat treat samples done? Okay. So here's what I want you to do with those. I want you to somehow label, engrave, identify your parts. And so you could just put them together and just put group 1 or group 2, or you can write your names on them. There's an engraver out there. And if you just put them on the granite table right in front of where that little glove station is, that way I can go back through those. So let's take a second and do that now. And then while that's going on, I'm gonna grab some parts for us to check, and then we'll get started with some other stuff. Sharpie? Yep. If you would not Sharpie them, if you would engrave them, because what'll happen is that Sharpie can get worn off, and I just don't want that to happen because somebody's gonna be like, this is mine, this is mine, this is mine. Out there on the big heavy table, as soon as you go out that door, you should see an engraver, and if you would engrave your stuff there, that would be great. So I'll give you guys a couple minutes to do that, and then we're gonna start on some other parts.
So unwrapped A2 was a bad plan.
So Jeff had told me that. I have never had that happen.
Even without argon?
We rarely wrap. And the only reason that it should not affect your heat treatment at all. It should only affect the decarb on the outside. But I mean, as far as the through heat treatment of the part, it should not change it one bit. Yeah, when he showed me that, he's like, man, it carved up like crazy. And I was like, well, that's unfortunate, but it should still, I mean, I could see it being a point or two low, but it was like 30, but other people's weren't. So other people had A2 that came out at 60, and they did not wrap theirs.
What the crap? The only difference would be that we baked ours at 1475.
You cooked your A2 at 1475?
Before jacking it up.
Gotcha, which should not make a difference.
So I have plenty of room on there,
Yeah,
but I would just put mine.
that would
on
be
there.
fine.
So
Yeah, totally fine. Let's see, I wonder if I have some tape that I did, or I almost need like a little container to put those in. That'll be okay, just get them over there, close to each other, and they'll be fine.
We'll wrap them up.
Yeah, I need like a little bucket to put them in.
Got an old windmill box. Well, I ain't gonna do that.
That probably won't be. Let me Yeah, let me go out and see if I can find something to put them all in.
Go on the trick book. Go on the trick book.
Did you get some?
Well, they sell them for a buck a piece here, but they don't. I might write her an email or say, I would like to buy 10 of them.
Where? Carl Lane?
Yeah, so anyways, you can request their trick book, which is, they have an online version of it, which is bad. I requested one. All of the crap in here. But, I mean, for a buck, if they're a buck a piece, I'll box up 10 of them, hand them out. Can tie.
No one did that video, I don't.
I'll submit them, tonight.
Yeah.
I don't know where they're going.
I think
We got about 4 groups. We got about 4 groups.
Okay.
So how about you put your stuff in there? Or just one per group if you would. Like, or is that your own group?
Yeah, that's the one.
Then just put them in there. That's your group. That's your group. Okay, and then what else do we have? Do we have other groups? Okay, and then I think we got one more group out there.
Yeah.
Okay, and that should be good. That'll just keep everybody from rolling away, having any kind of problems, and it should be good. Yes.
Alright, two, it's fine, keep it up. It's not be done till like 3:10,
Like some of the costs on it, so I get that stuff in the hole.
Right, so when, when it's unlabeled, you go to the closest adjacent dimension, and so that would be 10. Yeah, it's better if the print has an actual tolerance block on it, rather than to just being like that. So if you have QC sheets for the parts that you did, go ahead and just fold them up and put them in them buckets too, that way. So if you checked this part, then you have the QC sheet that you checked it from, just go ahead and throw it in the bucket as well. And then that way I can come in tomorrow, check so if you had part DK, I know it's one of them, grab that part, I'll just go through and do a quick check with it, and
This on there too, or?
you can if you want to, it doesn't make any difference to me.
You still have ours, right?
Huh?
You still have ours, right? 'Cause
I don't know.
I put it on the back of on your table with the piece and you moved it over to somewhere else.
Oh, you gave me the part and the print, got it, I'm sure I have it somewhere,
Okay.
it will be located. Okay, I'm gonna let those 2, 3 last guys get in here, and then we are going to do some round checking, so checking of the parts that you guys did, that you turned, in 101. Let me say this, in your 101 class, don't be in such a rush. You guys are rocketing through, which is great, I love the speed, turning out some junk. And so, take the time to slow down, make some good parts, get comfortable with the machine. Because I think you're feeling the pressure of I've got to get so many parts done. And you've got time, you guys are running way ahead. And so if you're just ripping these things through, just to getting done to get done, I think these guys who were CTC would tell you, just getting done to get done just ends up with a crappy part. And we've got the time to make good parts. So go ahead and try to make good parts.
Or we'd have people that was like 4 projects behind up there.
Exactly. And I think we have that problem all the time. Even my 135s this semester are doing a super fantastic job, but they kind of want to set their own pace. rather than the pace that I've set for them. And so I'll give them programs to do over the weekend or at home or, whenever. We pull that door closed, please. And what they're doing is they're doing most of it, and then they're like, I think I can do the rest of it while I'm running my parts. And so they stand there at the machine for 2.5 hours reprogramming their parts, and I'm like, but that's not what we're supposed to be doing, So, and I get it, but if they don't end up with their project finished at the end of the semester, it'll have a big effect. Okay, so, here's what we will do. We need to check all of these parts, okay? So there are 1, 2, 3, so there must be 10. So if you would come and get, so we can do groups by what do we got? 2, 4, 6, 8, 10. 2, 4, 6, 10 people. Okay. So we got 10 people, 10 parts. Grab a part that is not yours, okay? Because some of you guys are one-on-ones. Or grab a part not of a friend of yours. Grab the part of someone you hate, okay? And so you can use, this is what you can use. I'm gonna go get a digital height gauge, because we have not used that, but I want you guys to be able to see us using that. You can use the digital height gauge to measure steps. I've got the dimensions for the prints on here, so you can use the micrometer. You can use the calipers, you can use the output comparator, and you can use the digital height gauge on that. You can use the CMM on that too. I don't know that I think it's worth a shot. I think I would at least try it, yeah, for diameters or steps are gonna be hard because they're so shallow, but I think you can do diameters on that, okay? So, grab a top one and a bottom one, okay? I'm gonna go get the digital height gauge, and then we'll get all those done. There's your parts. So get a top one, not that bottom one. Sorry. Grab the bottom one, top one, and the bottom one. Yep. I'm gonna go get the digital height gauge, and we should then have everything that we need.
So does each group get one part?
Each individual, so there's 10 parts, 10 people, just individually get parts today, on this one. And you can use anything in the classroom, should be able to do it. Did you label it what it was? Okay, so just put it in that black tab, and then it should be some parts similar to it in there.
Damn sheet there.
We didn't punch on that.
Y'all want to hop on the computer real fast?
Where did he put the right? Yeah, but I think it's all right.
Yeah, it has the,
Except for the 2 holes. 0.5. Well, obviously, we don't.
If you want to use the digital height gauge, I've got one here that we can use.
All I use, I don't use it.
No, it's not terrible at all. So, zero it out, and it goes up to 6 and some change.
Hey, you said we use this, right?
What?
You said we use this, right?
You can totally use it. Okay. Just use the RDS on it, because that's as far as we've got. It is. You could definitely go ahead and put some deburring on it, so you can measure it. I would just take it, it's fine. Yeah, I put no on there, and so you just deburred enough to be able to take the measurements. So you can use micrometers out of the NC3 box if you want to. You can go get your own toolbox, do however you want to get your dimensions off of there.
What was the,
It's that's it, yeah. Yep, and then go to the arrow. Yep, and then go to quick measure. And then there you go. So you'll be able to do any of the diameters. So that's a really good idea, or a really good question. You probably can. I don't know that that would be my go-to on that. So let me see if I can find a little B block for it. If we could get a B block, we can probably get all those dimensions in one shot. I think I might. Actually, Austin, look through those first top drawers, like 3 or 4 drawers, and see if there's a B block in there. This may be way too high.
How would I turn this display?
There's a button in the back. You can use that. Just put the tail in. Yeah, it's probably strong enough that it's needed.
Which menu do we use on this?
That's the one. Might just be looking around a little bit. Well, which menu do you think you should use? So this will just give you, this is what you would usually see.
Oh, okay. Well, if we had it.
Yeah.
So we gotta move
Probably don't. Yeah.
Just we made that fancy stand.
So,
So when it says like measure the plane,
So.
what I would do is I would grab a file or a stone.
That's what I was wondering. So I would guess just,
off the.
yeah. Just stuff
Other
that
than
freeze
that,
off there.
there's some in the. Oh. Standard. Without chain wrapper. Anyway, people say it to you all the time. Yeah.
You may, if it doesn't work.
Okay.
you might have to-
Yeah, so here you have 3.125, so that's 3 places left.
Did it not work?
Too much like that.
No, so, this is just in 4 places,
Like-
nothing on there.
Yeah.
What's up, what?
I stoned the bottom of it,
So?
along with whoever's name was on there.
That's why I don't like
I
markup.
think it was CSB.
That's mine.
Alright.
It's crappy.
It's when you convert this over to inches.
Yeah, so just go,
Um,
you got it?
I'll just have him engrave his name on it.
Yeah.
Should've talked so much shit on it, doing it. I don't know, he's standing right there.
Wouldn't worry about
I
it.
think you take it. I don't know though, I may be wrong. He might be a ninja, I have no
You
clue.
never know.
Yep.
Seen Beverly Hills Ninja?
Mm.
Remember that?
I say that to people all the time, I'm like, I'm a Beverly Hills Ninja, and they're like, I'm like, I know you don't know what that
Don't even
means.
know what that
Yeah, I
means.
know you don't know what that means.
What do I do
He
about
was
this,
good.
this
Just
little
a little
nick
too
right
much
here?
So I think I just measure around it.
Well, no, I mean, I've already measured this, not a problem. It's just like, the part's not burnt free, it's got a
The
mass.
part is not burr free.
Yeah, it's got a
Yeah,
mass.
I think I would put in the note.
Almost died.
Yeah,
Oh.
yeah, this thing nearly cut my jugular. Yeah, I almost died from this.
Still working out.
You should just on the height. Or you.
It didn't make a difference till.
Yeah.
It'll work out. Cause like, if you turn it like that,
Yeah, it will not work if the arm is in an axis limit.
You want that one? That's an example.
Sure, absolutely. Just throw it in your group.
You can just ask for the sheet.
One thing you want to watch for, Austin, is when
I'll give you
when
this
you're
one,
measuring
Ben,
this,
so you can
that it's not
grade your name.
moving around a lot. I can see it move just a smidge, see that? And that will start to translate into error. So even if we need to take an Allen wrench and tighten that down a little bit, or, yeah, probably won't hurt. Any type of error that you're including into it, just means, just bad for the parts, really.
you
You guys should in your toolkits, William got his in here, he could probably borrow his and get it.
All your Allen wrenches.
There you go for it.
Is that metric or standard?
I think you made it.
I know, but.
I think it's standard.
I think it's standard as well. Oh, so this one says 83 as well, that must be the series. Check out how much bigger this dude is than that.
Yeah. See, ours are even,
Bigger than that?
yeah,
That's.
they're probably about 8 tall.
We got nothing that fancy.
I'm telling you what, you guys should have something like this at your shop, Austin. I know they probably won't buy it.
Todd's kinda cheap on some stuff.
I just think that Todd's gotten old enough that he doesn't really pay attention to some of the new things.
I think it's really weird that they'll spend money on some high dollar stuff that's like stupid,
Yeah.
and then they won't spend money on,
The things that they need to.
Like our place, multi-billion dollars. We're fighting for mills and grinders right now, but if they need like a $25,000 printer,
Go for it.
yes,
Yeah.
sold.
Yeah, and I think that happens everywhere, so. Yeah, I'm not sure. There should have been another one. And so when I opened up the box today, the guy just brings it in and just kind of slings it off the pallet jack, and I was like, doesn't look like $80,000. He's like, what? And I was like, it's fine.
Was it a state fair guy or was it?
It was a state fair guy. I was like, it's totally fine, it's totally protected. And, so, no, that is just calibration software, or calibration tools for it.
Don't
You don't need that, yeah. I've got, so our, filament comes with bags bigger than that, and so I've just been collecting them. And I'm gonna put them in all the toolboxes, once we get enough of it. So yeah, this one came today, and there should be another one on the way with the scan head.
Used for things like that, similar build, structure, not quite as shape.
Do I have a use for one? I do not. Yeah.
The diameter.
My grandma gave me this case a while back, a long time ago. It's an old, bow, valve
It's only one decimal.
count.
Oh, it's 20.
Yeah.
Oh, yeah, that's.
That's cool.
Yeah, but I mean, it's like this tall, probably a gay wide, you probably get that gay wide too. I had some problems with something.
That's what my son thought.
Did you get good dimensions?
You done? Any good ones, like in Holland? Might be one.
It's like, cause I think I have an idea. And then put the bit.
So you got all your diameters, it's just gonna
I
get
got
that.
diamonds.
You, okay, got it.
I wonder if our finish isn't very good with my tools.
Like, we usually put the lines like the mini threads, and it might be really like thin parts better across. I'd like mine to be auto thin, and then I go like really slowly fix it up.
I did pretty good.
No, they just fix your bed.
Cause I have one of those like
Like
triangle
a
bit
bit.
things. I feel like if I had a bit like what you had, it would have been a lot better. For mine,
There it is.
Yep, nice.
I don't know how.
Knurling tool. Supposed to be like $700.
And that's a force.
Big.
Really?
So it's like, you know, it's got lots of spread on it. But it actually, instead of like going into the part like
It's so sad.
B, you start. Feed the cross road. You can get like one that'll turn out really awesome looking, and the next 5 will look like crap, and then the 6th one will look good.
Really? I've got one with a Dorian, and I paid about $600-700
I
for
think
it.
that's what it is.
This is a beautiful one. It's spring-loaded head on it, and it just has the 2 rollers, much like a manual one. I love it.
Total height.
You got them all.
Total
Oh, it
height
doesn't have
is
any
less.
holes that are deep, so I'm.
Oh, that's a typo.
Well, up here.
Hey, when it says stamped or engraved, does Sharpie count as stamped or engraved?
Yeah, hopefully, Clint will start saying that that is not acceptable.
I like it first, I would think that's something we're talking
Hey, as far as the plane,
Mhm.
does it really matter?
Yeah.
So,
So I would do
if
the,
I'm down here,
it's still this plane.
okay. I don't quite understand.
So that's what keeps it, so when it's planed like that, when you take dimensions, it's saying this is the center line.
It's perpendicular to that or whatever.
Yeah, so this space, and then, cause otherwise, you're kinda just doing this angle-y thing, and it's not gonna know what to do about that. That surface area looks terrible. If you're done, it goes here, check sheet goes there.
I was gonna get this stuff high.
Okay, so yeah, you can use optical comparator, you can use calipers, you can use height gauge.
about. I got one measurement to get.
I'm assuming the bottom is the 0.9.
Yes, it's the largest diameter is 0.9.
I don't seem to remember the thing going balloon like that.
So they've got, like when I was at Hexagon, you can change the tones on it, and one of them was Homer Simpson, and it goes, oh! Every time it does it, and I was like, that would get pretty old.
There you go, you go on that one down. Sorry. What's your name?
Cameron?
Cameron. Looks like it's a camera on. Oops. This was it. I emailed that girl, or emailed that place about getting locked into 20.
What?
Also submitted the form. Just work ass. What expires?
There is one typo, there's one extra thing on there.
Well, also it says staff guidance.
Oh, it does? What? You choose, because that's not a square edge. I'd say that, I made this like. I want them, yes, please. Yeah, I'm gonna give these to Clint Monday morning, and, well, I'll leave them here for him Monday morning, and then he will take them. I have one other part that we will group into, I did 3 of them. And so we'll have to do groups, 3 groups of 3 and 1 group of 4 for the next one. Yeah, someday I'll have all of these QC sheets done and everything.
You want this too?
You can, yeah, that'd be fine. You can just stack it here, put your part there. That's a terrible stacking job.
Got a list there. It's not fine.
Yeah, that's way out of time. Thanks, sir.
So I emailed them about getting 10 or 20 of them, but they didn't necessarily, they had a request for a single catalog. But for all my students, so they might be like, yeah, sure, okay.
Yeah, I would actually, if you would send me an email, I would just buy a whole bunch of them. I mean, it won't do necessarily your shop any good, but how many do you need for your shop?
No more than 10,
Okay.
probably were 5 really.
And then were they really, they were $1 a piece, you had to buy them in 10s? I'll buy
Well, that's
50
what they
of them.
said, but they didn't have a link to actually purchase them.
Oh, okay.
When I Googled it, these little trig bugs.
Carlene Trig book?
Oh, is that them both here?
That's a mistake.
Okay, I was gonna say.
No, you gotta go out and drill some holes in it.
Yeah.
Dealer's choice.
I've got half of them back. If the other half of you guys could,
Did you just want us to send these in with the tray up there?
yeah, if that was part of the group stuff,
Yeah.
then yeah, all your group paperwork goes in the tray.
Yeah. Email sent.
Cool, thank you. Yeah, stuff like that, I don't mind just grabbing those things. Yep, just got it. And usually, a lot of times on school stuff, they'll say, you need 100 of them? No problem, we'll just send them to you. This Starrett, Tools and Rules, have you looked in it? It's got some stuff like that in there too. And those are free. And I gave you guys some of those, and if you want more of those, I can get you them. Anything from Starrett like that is free. You just log in, and you just tell them what you want. You don't even have to be a school or anything. But, let me grab you one and refresh your memory.
Yeah, may or may not have one, but.
Do you want this sheet back or does that matter?
Yeah, you can put it back on there.
Both of them?
Stack them up there, yeah.
I don't know if I got that one or not. Yeah. Well, this
Yep.
I don't know, probably,
And so it's got like speeds and feeds, depth of threads, angles, tapers, conversion charts. It's got a lot of stuff in it.
let me try to get one.
Huh?
Let me try to get me on my cell phone, there you go.
You one of these?
Yeah.
I love one. There you go. That's even got a standard and metric conversion chart in it. I feel like I gave those out.
Remember getting something, but I don't remember what it
Yeah, so I just
is.
called.
Little green books. Little green
Those are
books.
Haas, those are the
Yeah, the
Haas
Haas
code books,
code.
yeah. Well, we got a couple seconds, and maybe I just gave them to our 101s and our 135s in PMI. Does everybody have one of these? Okay, anybody not have one of these? No, I gave them to, so you guys might not, you should have got one. Okay, so here's what I'll do, if you don't have one of these, so if you took PMI, then you should have gotten one, but if you didn't, come grab one of these, and then I got some other things to give you as well. Okay, so here are metric charts, standard charts, and then some notepads. No, I don't, I want to try and keep the materials plastic. So that's just that's free Scarrett stuff, but it is pretty helpful. Alright, Jason, did you get some of these? Grab one of each. And you can throw in your toolboxes, that's where most people keep them in there. And then that way you just got it. You can have those, yeah, I'll just charge your account. I'm just kidding, yes, you can have those.
Listen, my account's out to the DOD, so I'm fine with that.
Well, hopefully your all's accounts, and I've said this 100 times, but tomorrow is my day to go talk to them about scholarship stuff. Hopefully that conversation goes well and quick, and then we'll send out some scholarship money, because the school, another part of the school called me today, and they were like, please get your scholarship stuff done, and I'm like, you're not waiting on me. I mean, maybe they are, but I'm gonna try to have that stuff wrapped up. Everybody have their round parts done? Jason's coming into home plate. John's, yep. Who else? Let's see, that is 3, 6, 10. You can just stack that here if you want to. You just, yep, perfect. Great, thank you. Okay, so now I'm gonna try to make a quick switch with my cable. See if we can move to another device without too much problem. Nope. Let's see what we can do here. Sorry. Not enough lane. Alright, so I'm going to shift this over a bit, just so I can get everything hooked up and plugged in and ready to go, and hopefully will work. Bingo. Cool. Okay, so we're going to move out of so the camera can see it. Because I know we've got a couple people out, and I want to make sure.
And you unlock the door.
Is it locked?
Yeah.
Won't hurt anything.
High-tech stuff.
Yeah. Okay, so we're gonna move away from RDS. So RDS is kind of training wheels for us. It's beneficial. It works great for us. I hope to have this on your all's laptops soon. That'll depend on Hexagon. There's a program that we use that does all of our measurement for us. It's called PCDMAS. And I'm gonna come in here and I need to.
Plain line point.
So, boy, I tell you what, we had a long discussion about plain line point when I was at Hexagon. And plain line point will work, but plain, way better. And what's that?
Be a lot easier to remember.
Plain, yeah. And so, you know, when I was talking to the guy from Hexagon, he's like, yeah, plain line point works, but plain's better. And he started telling me about why, and I was like, oh, that actually makes a lot of sense. So, anyways, he was really smart, did a great job. I'm having a hard time remembering what some of these commands are right now. I'm trying to figure out if I can remember what pan is. There we go. And okay, so this is the part that we're going to measure. Can you kind of see what it is? It's a rectangle shape. And if you come up here, be careful because there's a bunch of cables and stuff. Looks like this. This one has been made 2 times. And so this is just parts that the students were working on pocketing on the CNC using G codes that were already built in, so CAN cycles. And so what we have here is just a round pocket and a square pocket or rectangle pocket. And so we're gonna write a program to check this. And so what we have to start thinking about are where are our absolutes for this. If you can see on the screen, X0, Y0 for this part is here. So there's not a program written. What we've done was imported a model. So drew it in CAD, drew it in Fusion, Inventor, whatever, however you draw. Put that in there. And so what we're going to do is we're going to establish 3 planes or a plane and 2 lines. And so if you'll remember me talking just a little bit about GD&T in the beginning, your datum A is your primary, datum B is your secondary, datum 3 will be your datum C will be your tertiary. So that's just fun to say. So this will be A, okay, primary. This will be B up here, and then this will be C over here. When you take all of those together, plane, or plane line point, or plane line, if you do them in the correct order, A, B, C, it will then put your trihedron right here. Your trihedron is that little XYZ thing that looks like that. And so from that point on, you can start to take dimensions from this and be able to create a program that will walk anybody through this. So you can write a program. And then, so Cameron can write a program, and then grab Abby, who's not in this class, continue 101 class, and say, Abby, you can go in and check those parts. And she's like, I don't know how to do it. All you gotta do is follow the instructions. So that's really good. So what we want to do is we want to establish a good way to measure this, a good, safe, secure, stable place. So we'll put it down on our table, move some of this other stuff out of the way, and just clamp this baby down. And so there is several different ways of doing this. This will just be one way that we're talking about today. So I've got it clamped down on the table. And so I bring up this model and I start to create a program from it. We're going to learn what all of this stuff is, but we're going to baby step into this thing, okay? So I've got my part on there and it defaults with a place where it thinks that the trihedron should be, but I have not told the arm, where the part is, or the part where the arm is. So there's no relationship to each other right now. And so if I bring in this, after it's got an alignment, it'll know where it is, but right now, like, you can't see the end of the probe in there because it doesn't necessarily know what's going on. So we're gonna come in, and we're going to use a magic wand. So it's called Quick Start. Quick Start is so dang simple. So far, when I brought this program up, it came and defaulted to these things. Load probe, D3L50 probe. That is this probe. This is the probe head. I know that because it says when you pull this off, it is the D3L50 probe, okay? And so we're going to learn about what the difference in all these Ruby types and stuff like that are, when and why we would use them. So here's what it says, is we're going to come down and we're just going to pick the things that we want to do. Calibrate probes, we don't need to do that. We've already got a probe that's calibrated. Alignment. Alignment can be done plane, line, plane, line, circle, plane, circle, circle, plane, line, point, cylinder, point, line, free alignment, 6-point best fit. Okay, so we're going to go here and we're going to go plane, line. So it's going to go A, B, C. So plane for A, line for B, line for C. So we're going to go in, and so we'll just work left to right, up to down. So we've got this one, we don't need to calibrate. We're going to go here, plane, line. And so it says, you're going to hit your plane, you're going to hit one of 3 hits. Or it's hit 0 of 3 hits, it's going to hit 1, 2, and 3. Come down here, I'm going to hit on the top. I'm going to go to the extents, and then, okay, now it moved me straight to the next thing, and I'm going to go to a line. Let's see, I go B next, hit, push the button, do a line again, and push the button. I'll get around to it so I can hit the button. Okay, so now it's created an alignment. It says alignment 2 up here in this box just because I did an alignment earlier and then deleted it. So this is the second time I've done the alignment. Now it shows, see how the trihedron is now in a different place from the edge of the point or edge of the part? It's because I haven't measured the part yet. It says, okay, well in relationship to where the arm is, this is where my part is. I don't have show probe on, but I can turn show probe on. And then it would show the probe being somewhere in there. So it says, okay, well, if that's the alignment, I can do that, but you just need to now start taking some measurements. So I go back over to here, and I want to do a measurement. And let's just say I want to measure the circle. I can do a measure single point circle. That would be like for a really small hole. Smaller than what my ruby is, where I set the ruby down into it, hit it, and it would find the center point of that. We're going to do 3 hits. Okay, and so maybe that's all I want to check on this. I can check as much or as little as I want. So now I go to create a dimension. And I can create a dimension distance. Let's see, I might do it like this. I'm going to jump out of this. So I've got my alignment and I've got my circle. I'm going to go up and I'm going to do my dimension distance over here. So I jumped out of the magic wand and just go straight to dimension. And so what do I want to do? I want to measure from this line to the center point of that circle. Okay, so that's line 1, right? To the center of the circle. And I want to measure in the y-axis. I know it might be a little hard to see. That dimension should be on center line, so it should be 1.0. Let's give it a plus or minus 0.005 and 0.005 and then create. And now let's go to line 2. Line 2 to the circle in the x dimension should be 5.0 plus or minus 5. Create the dimension. Close. Okay, so all I did was create a measurement cycle that aligns the part and measures the hole to where the rest of the part is. I go over here to this play button, and it tells me what to do. Take hit 1 of 3 on the top plane. Take hit 1 of 2. Take hit 2 of 2. Take hit 1 of 2. Take hit 2 of 2. Measure the circle. 1 hit of 3. 2 hits of 3. 3 hits of 3. Stand by.
Could I take 5 hits instead of 3?
I could. Yeah, I'm gonna back up on that one. So that's a good point. I can hit that. I just have to do my minimums.
So you could just like fold it down all the way around the circle,
Sure.
measure all over.
Let's go back and we'll just do that again. So let's just do that. So we'll do plane. And so now I can go see how the trihedron moved to where it's actually at. Corner's there. I can come over here and I can really do it 2 different ways. I could run my report. My dimension of 1 inch is measured of 902. My dimension of 5 inches is 5 inches 23 thousandths. This part's trash. Now I didn't do one that was the circle, but I could. So let me go back. Now that I've measured the circle, I can go into here and I can go, let's see, what's going to be my best one to do this? Diameters can be a little tricky. Can do positional and get the diameter from the position. Actually, let's do it concentricity wise. Circle, create from line 1 and line 2. Or circle, diameter, turn X and Y off.
You saw it only selected line 2 instead of line 1 and 2, right?
Yeah, I changed my mind. I went ahead and went here. I could actually do all of it here. I could go X, Y, and diameter. So I could hit here and go 005, 005. And let's put 0.005 tolerance on this guy as well. And then create, close, and this would also tell me the same thing. So I'm at X 5 inches 30 thousandths, I'm at 953, I'm at 1.7527. So I get a little bit different dimensions from that. My Y is really close. I should have set this at my nominals at 5 and 1. I can go back and change those though. So let's just set that at 5 and -1, and let's say that's supposed to be 1.75, and then create, close, and create my dimensions. So there, I'm 5 inches 14 thousandths, 902, 175, and almost 3/10. I'm 9 thousandths out of tolerance, I'm 93 thousandths out of tolerance, and then I'm in tolerance for that one. And so just a couple of different ways of doing it. So now, I'm going to take these two out. And just leave this. So now when somebody comes up and I just want to say, hey, go check this hole, they can come up and do this part. So all they have to do is hit the play button up in the corner and do the steps. Who wants to try? Come on. I'm going to give you, I cannot give you the laptop. You'll have to watch the screen. So I'll hit this for you. I don't have enough cord.
Where should I stand? What side?
You're good. Whatever's comfortable for you. So take hits 1 of 3 on plane. So if I was going to do, like if this was our part that we were going to manufacture, I would say do this on the A plane, and then you would, like I'd get more specific on it. There we go. Okay. That's B. Yeah.
You gotta accept.
You do. So you're going to have to, after each thing that it does, line, plane, point, you're going to need to accept what it is. And then now you're going to scan the OD or the ID of that.
Same thing if you wanna delete with the other one, you just hit the back button.
Yes. So we scanned it last time.
Oh,
so
okay.
yeah, when we did it, so you actually have to. It'll work out. It may need you to redo that.
Okay. I can try hitting the back button on this.
Yeah, I don't think that it's got a back button. Let's just go through and do it again.
Okay.
It's got a back button, but it doesn't back button when it scans. Okay, now 1 of 67, so scan around that probably. And hit the button.
Just taking outside of tolerance now, I can try it again, just don't play it.
Let me back up here. I'm going to go back to the alignment. Let's go back to 3 hits for the circle.
Alright.
So when you take your hits, take them anywhere across the top, and then on the bottom go left to right, and then on the other side I think go top down for it. See if that helps it. Let me put you into execution. Okay. And that's it. And so I go down to the bottom here, and then I hit my report, and lo and behold, it's still out of tolerance.
I couldn't fix it.
Could not fix it. So that brings up a good point. Sometimes, if you are the QC person or you are doing QC, you can trick some things. I mean, I've been at fault in doing that. I've also seen other people do it, trying to make a bad part good, hitting it harder, hitting it softer, in order to try and squeeze some dimensions out, you know, because what you're looking for is the CMM report. I've seen people take a bore that was 6 thousandths too big, wrap a piece of paper inside the bore, measure the bore, because the piece of paper is 3 thousandths thick, so all the way around it's 6 thousandths smaller, measure the bore inside the piece of paper, print the report out, and they're like, it's good. I'm like, it is good on paper. It's not a good part, you know, that ultimately ends up with a rejection from it.
You gotta physically be touching something with that ruby,
You do.
Paper.
Well,
you know what I'm saying?
you don't. No, you could just,
air point
you could air point it, yeah, you could just totally out in the clouds, you know, just go crazy with it.
The ice we got yesterday, it moved about a foot and it like block up the stop. I don't know what
Really?
that was.
So,
Lakeland, that's what finally started working.
they can be a little tricky. The great thing about a CMM is, they're pretty reliable because they don't make chips, you know, and now what I've found, so I've had this one totally stripped down. We've done a ton of work to this one to make it what it is today. But a lot of it, like to retract the head, it's done by a string and what looks like a bait caster is what pulls it back up, you know, because I mean, essentially it just needs to move back up, you know, and I'm like, that's weird. So, but it actually works because all it has to do is pull it back up, and it always measures going down. So it's always using the servo and the encoder to measure. It just got kite string pulling it back, you know.
And the string's probably smoother than a chain too.
Oh yeah. But like on the back of your CMM or your CNCs, you know what brings the spindle back up most of the time?
Counterweight or something.
A big old counterweight, yeah. I mean, and like on some of the Haas, they have a nitrogen cylinder that helps to pop them back. But a lot of them, I mean, are just a big old freaking set of weights just hanging back there. And all it is just gravity brings it back up. So, yeah, just one of those things. So, okay, let's take and do a couple other things on this. And so, I'm going to pull this back off of it just because I don't want it here for right now. And now if I wanted to measure, let's say I want to measure the square here of the part that I'm working on. I can go to measure a square slot. Let's see, let's turn that back in. And actually, let's do it like this. Let's measure a line. And I can come over here and do it again. Measure a line, come over here.
What's the color change supposed to mean?
Whenever I've got it and whenever I've got an axis locked or too far, it changes color and it won't allow you to click the button either. So I'm clicking a button and it doesn't do it. When I pull the wrist back, it'll allow me to do it then. And so it changes color then. And so now I measured these 4 lines. And so with that, that tells me a whole bunch of stuff. I should be able to figure out where this part is in relationship to everything else. So I can go and do a distance dimension from line 1, which is my line up here, to line 3. and the y-axis, and I haven't given you guys a print yet. Let's do 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. So take 1. Take 1, 1. So group, and group. Yep, you pass it on over. Okay, so that dimension nominally should be 375, correct?
Yep.
And tolerance is what?
10,000
10 thousandths.
plus or minus.
Okay. So I can create that dimension. And then I can go, how is it? Okay, so then I could go this line 3.
Yeah, to the bottom or the other side of the pocket.
Yeah, so that would be to probably line 4. And it's supposed to be 1.25.
Yes, same tolerance.
And that's in the y-axis. Create. Then I can do line 2 to line probably 5.
So normally stacked up all like that, or what's it?
Yeah, it'll be,
Like where it's right next to the triad or whatever?
yeah, where the trihedron is, so I can pull them out.
Okay.
So if I want to see those, it's not going to be super great because I have not rerun the part yet. So they won't really look like the right thing until.
And that way you can look at the picture and say, that's line 3 over there.
Exactly. So now at this point I just have to either know them or I can come in here and do this. So measured line 3 was the top edge of this, right? So I can come in here and edit it. Top of slot. Bottom of slot. Let's just say this is the left of slot. I don't even honestly remember. And we'll do right of slot.
Definitely helps create a pattern when you're doing these things all the time.
Yeah. So like I think everything in what we do is kind of about measuring with some patterns. So I go back down to here. So I need to be at that right spot. So I can't, if I start taking measurements here, it will start putting them in here. So I can control home and then control end. I think it's control shift end on this one. And then, so keep measuring through here for each one of these dimensions. So let's see, left of slot to right of slot is supposed to be 2 inches, 250 maybe.
Yeah. Yeah.
And it's a plus or minus 10 dimension. And then, okay. So I've given you a few dimensions, showed you how to do it at this point. You have a couple of minutes, so we got about 10 more minutes. So why don't you guys just come up here and all 10 of you and start playing with this. And so we'll start recording dimensions Tuesday. Okay, so we'll keep working on this, but I want you to get a little bit of a feel for it now. All right, so the helm is your all's. I will be happy to answer any questions, but I think it's easier when you guys are taking some dimensions and collecting data. You can, let's move it down a little bit. That way everybody can get. Okay. Do it. Jason, grab it. Grab the helm. Okay, you can also measure the bottom of the circle too, right? So the floor of it. So you already have this, right? Yes. You knew that because I was shaking my head, yes. Yeah. Okay, so so maybe I just want to do it here, and I just want to do a single point, a measured point. So I'm going to go to point. I'm going to bring this thing down. I'll do one, then you do one. And so measure the point. And so it stays in point until you take it out of point. So now if you want to measure the bottom of this circle, do it as a point.
So that would be point one and then point two.
Yeah.
And then measure, well, we have the plane already, so we'll go point one to plane one,
Yes,
point two to plane
one. It's just 40 grand. Just throw it on the floor.
Half price the other one.
It is half price of the other one. Well, the other one was a two per package, so they're each about 40,000. So, okay, so you got 2 points, right? You have a point and another point. I don't think you hit that. Did you hit that? Okay. Okay. So now you've got 2 points. Now what I would do is go ahead and go in and name those. So what I would do is I'd come in here, hit this, right click it, edit it, and I would call this bottom of the rectangle. So flip it up so it rests on the little, yep. So for our last, is this week 5? This is week 4. 4. This is the tail end of week 4. So for our next 4 weeks, this is where we will be primarily at. On one of these CMMs or one of those CMMs. So we'll spend a lot of our time in that. There's a lot of things going on. So you're not going to be able to be like, I'm not really going to pay attention, but I think I can fumble my way through it. The thing about PCDMIS is it's not a fumble through kind of program, which so there are some programs that are like that. They kind of tell you what to do next. This is not one of those that does that. And that's probably its one major flaw, is that it doesn't necessarily help you get to the next point. It's expecting that you would know the next point. So like it's saying, Jason, what do you want me to do next?
Now we need to apply
Sure, you could go ahead and
dimensions to it, or.
you could go ahead and apply dimensions to it, or you could continue to take dimensions on the entire part and then take measurements at the end.
So what's the easiest way that you find to do it? Do you do it one feature at a time, like if you need to measure the depth, your width, length, and radius? Will you do it one feature at a time and then go back and punch in your nominals, or?
So yeah, so what I do is I don't take any dimensions until later. I get the entire part probed. So I do my alignment, and then if I were doing this part myself, I would come in and do the alignment, and then I would do the square, the rectangle of it, the bottom of it, the corner radiuses, and then that would be done. Then I would come in and do the circle, the bottom of it, and then that's all I would need. Everything else, from that point on, I've got everything. So at this point, you've got now the circle, the bottom, the rectangle, the bottom, the alignments. You need to get the corner radiuses, so 4 corner radiuses on there. And then if you want to, you could get this dimension, this stock dimension, and then this overall cut length dimension if you want to. So the one thing about the CMM is a lot of times I see people not doing certain things, but then they end up, because they're like, oh, it's another thing to check, but then they use the CMM for 90% of it, then they go grab their calipers and measure their overall length. I'm like, but you were already there. Why didn't you just let the CMM check it? And that one over there moves by itself. So Like, you don't have to do anything, like, you just literally put the part down.
There you go.
Yeah, and then so they'll be like, oh, I checked 90% of the dimensions and I'm gonna caliper the rest of it. I was like, why would you do that? That's like microwaving it halfway and then being like, I'm just gonna oven cook the rest of it. Well, you were already there. Why didn't you? It's a burrito, you know? It's a hot pocket. It's gonna be crappy anyways. So,
I have a full radius, like a circle.
so yeah, a circle would be a great place to do that. So next we want to do is come in and we want to find a circle. So we'll go to a circle and we want to measure just the corner radius of that. Okay. Circle hit takes 3 hits
Within the radius.
within the radius. Correct. So just make sure that you are. I'm going to mark it for you. Be within that zone. And now hit apply or OK or just a little button left. Hit take. Yeah. And so measure circle. So it's a measure circle, but you're just going to get the radius off of it. That's fine. So you need to do. You got 3 more of those to do. Make sure you're in the circle.
Don't touch the flat part.
Yeah. So just this section right here. Were you in that section? Yeah. Okay. From where I was standing, it just looked like we were out of the front circle. So if you're good, then you're good.
With my mask. I gotta wear it work.
You'll know if you get this crazy.
You like holding the strings back?
Yeah. It hurt with my big old beard.
Okay, so 4 of them.
Little people with masks.
Is there anything else that you need to do on the part?
We need to do our thickness and our overall length.
I probably would. I would do this dimension and this dimension. Jason, pick somebody else to do the rest of it. Austin.
You just like go up here and hit like a square rectangle.
So what you may want to do is you could do a line. You could do a point. So a point is a single hit. A line is 2 hits. A line is obviously more accurate than a point. But, you know, that's stock dimensions, so you could probably do about whatever you wanted to, either a line or a point. You can't do whatever
So
you
you
want.
do line this and then this would be a separate
And then
line.
that's a separate line. So you're gonna have 4 lines.
There's not just a plane.
You could do a plane if you wanted to do a
Plane,
plane.
plane.
Yeah, you could do this, a plane, and then do a measurement plane to plane. Yeah, you could do that.
Well, didn't we already get this one then?
Yeah.
So we're just gonna do
So
the
you
top
just need
one?
to get that one, yeah. I think it's everything. Okay. Everybody agree with that? It's everything? Okay. So what we'll do is we'll stop here. I'll save this one for us. We'll come back Tuesday and I'm gonna give you some video stuff to watch on the CMM so that you can start to kind of get a feel for the CMM. It's really just some recordings of some CMM classes that I took before. Help you get a little bit of an idea of how alignments work and some other stuff like that. We'll work on that all next week. So I'll give you a little something to do for Monday, but it won't be anything super intensive, so. Alright.
Like classroom work, nothing?
It will probably not be, it will probably be a video.
You could come to class and watch some of it.
You can come to class with a video,
I'm not doing
but it'll
that.
probably just be video. And then I would love to say from this Monday, starting this Tuesday, that'll be the last time that I'm gone, probably won't be. So,
I'd be tempted to come in and just throw parts. and-
You can absolutely, that's a great point.
Yeah, I might want to do that.
If you want to get really good at this, you cannot mess this up, okay, you really can't.
We don't wanna move this target.
You do not, well, if you do, you're just gonna start over, and there's nothing wrong with starting over. So, log on to this computer, if you wanna come in at 1:30 and work till 3 o'clock probing these parts, or working in some groups probing these parts, that's totally good to do, because we're going to be spending a lot of time doing this, because the more, with 10 or 12 of us in here, the more time that you can get alone to do it, it'll be beneficial for you to do, so.
That
Yeah.
program, if we had this all done, everything, was that straight over to that?
Yes, you just have to change probe heads. You just have to tell it, I'm
You
using
tell it, you know,
a different probe head.
0, this right here.
Yep, and so same thing, if we go from CMM arm to CMM arm to CMM arm, all you do is say, I'm using this size ruby on this arm, and it'll do it, so. Alright, that's it. Have a wonderful afternoon.
Can it also go from CMM to CMM1?
Yeah. All you have to do is tell it that it's automatic, and what probe you're using.
That's cool.
Since it helps that they're the same brand and that they're the same software. So if one was like a Verisurf arm and then you had a hexagon, there might be a little bit of,
Variation.
might be, yeah. But, so like Verisurf was one of the ones that we looked at, and you can actually put Verisurf software on your hexagon machine and then again have them all back to the same thing again.